Okay, mic check. Okay, I'm gonna turn up the fan now so you can hear me a little bit clearer. Hello, so this is supposed to be the third video, but I forgot to stop recording in OBS and all the footage is lost. That is why I have to do this thing. So, a bit of a recap. In the first video, we've already made a list of the requirements for the new version of the laptop case. So, I'll show you the old version first. So, this is the old version. I added some cooling vent, mounting holes and stuff like that. But yeah, as you can see, it is just a simple rectangular over here, and the fit is not particularly good because the laptop, the this one, okay, see the side of this thing, it has a bit of a bevel, so I accommodate that in the new design right here. And because the first version is mounted on my left side when I'm working, so this side will get mounted to the side of the table. But now we have to rotate the thing, because now this side will be what will be mounted to the table, and the laptop will be onto my right and not my left. So a major difference there. Now, why do I go for this design in particular? Well, firstly, because in the first design, the laptop the laptop pokes down at this area. So the laptop is of course much longer than 250 millimeter, so it pokes out quite a bit, and it usually hit my knee when I try to move sometimes, and it can lead to issue of damaging the laptop or completely dismount the entire enclosure. So that is why in new version it is mounted to the neck of my PC, and it is basically just glue using double-sided tape down to the base. In that way, I don't have to worry about creating mounting holes, making sure that the hole is flush so I don't scratch the laptop. That is the first point. The second point is about the cooling problems of the laptop. Now, I made, because the old version is completely sealed off, I have made some vent. And to be honest, it's not just a vent, it's basically a cutout. So the entire thing is cut out, and there's only a teeny tiny, I still can't get used to navigating with this. So yeah, there is nothing holding it on the side, and only a tiny piece of plastic holding it by the lip right there. So this is the new orientation. So only the lip at this section, and this section is holding the USB dock, USB hub, USB hub. I'm sorry. And I think there has been some oversight about the mounting, but overall I think I'm good, to be honest. I think I have cut it a little bit too deep, to be frank. Okay, so it didn't need to be this deep, but will it affect the structural integrity? Because I don't want to create a support in this region. You know what? Let's try to export the thing. File, export. Wait, have I? Okay, I'm recording. Okay, the body. File, export. FreeCAD, laptop dock. Okay, and STL mesh. I'm gonna open it in Bamboo Studio. I'm trying to I am trying to improve my intonation and pronunciation. So I probably should speak a little bit slower than the speed of my mind. Okay, it is very closely fit to this, but let's rotate this. Also rotate, yeah, rotate 180 degree. I don't know what I'm expecting. 90 degree. Here we go. Okay, and this side should be what is touching the base. Yeah, definitely. Rotate 90 degree by the x-axis. Very well. Okay, now we're on to something, and we will hit slice. Three wall. This is three walls. I think the print setting for multi-board tiles is pretty good. 19 hours is it's not that bad, but look at the overhang. I want to see the overhang performance. Overhang walls, cross, bridge. So I have a lot of bridging here at the lower and bottom, but it seems to be able to handle it. Very nice. Yep. What I'm a bit worried about the flimsy structure over here. I don't know if my printer can handle that level of, because the bamboo printer is quite fast, so I don't know will it wiggle too much and cause the print to fail. But yep, this is a good observation. So we are not damaging anything. We're not affecting the structural integrity of this. Now I would probably want to adjust the thickness of this thing. Most definitely. It doesn't need to be that deep. Maybe, I don't know. Having some form of hollowed out section can be benefit to a degree. To be honest, why not? I mean, the section is going to be covered by plastic anyway. Why not just cover it? So going to the hub charger and vent pocket, I think I can increase the depth a little bit more. So it's currently 35 millimeter. How about we go for 40? Okay, nothing much. 50 millimeter. Something is happening. Let's go back to 35. I think I'm missing something. Okay, we can go to deeper, so 40. Okay, so 40 might be the limit, because as you can see here, I've already broken through the wall and yeah, create a cutout for the lower section. Yeah, this is inside already. Okay, so now less material is being used and more vent for these objects to be cooled. Not bad. Okay. I still have no solution for the mounting option right here. Quite a bit of hassle, I know, but should I just stick to the method that Theo Joe, not sales show. Something about 3D. Nope, not this one. Yeah, not like this one, but something a little bit more like a very big YouTuber who like to use aluminium in his projects. And what is his name? What is his name? I don't know. Let's. Nope.
I just docked it and that is incredible.
I've been thinking of a laptop stand for a long time. This has just blown my mind. I haven't thought of this idea. A vertical slot mount
On the side of this.
freaking genius.
No, not Theo Joe. Something like what do we call some like monitor riser DIY. This is DIY perks, something like that. Yep, DIY perks, and this is his solution.
Cut out in the middle, which makes a small gap for 2 fingers to make the laptop easier to pull out. To finalise this, cables and a power port extension. With the laptop in position on the dock, these cables can all be plugged in, after which we can mould some tack around the area of each plug to prevent the glue we're going to use from touching the laptop or spreading too far. You may want to make some grooves in the base as well to give the glue something extra to adhere to, and it's a good idea to rough up the plastic on each connector for the same reason. The glue I'm using is slow drying epoxy, which has a working time of about an hour. I'd recommend this over the fast drying stuff, as those often set within 10 minutes, which makes it a little bit stressful as you'd have to rush to get it all done in time. So once it's thoroughly mixed, it can be spooned into each tack mould, as well as being added to the underside of each connector. You need to take care when plugging these in so as not to let any glue enter the port at all, which would be quite disastrous for obvious reasons. Once it's in place, some more glue can be added up the sides for some extra strength. They now need to be left until the glue is completely cured, and it's important that they are in a very neutral position for this, not being pushed in any particular direction, so that they will be perfectly in place once set. So once it has set, the tack can be peeled away as much as possible, which leaves the ports solidly and securely in position. So much so that the laptop can be slid in and out and they'll remain securely anchored as if set in stone. Now it's time to tidy up the cables, so we can bundle them together with a cable tie and get some black cotton ribbon, wrapping it around and around to tightly bind them together. This makes for a single exit cable that looks really smart. So now there's only one thing left to do, which is to make a covering piece to hide the connector. 2 fingers to make the laptop easier to pull out. After which the dock is complete. So with that, we can now plug in all of the devices. I used a USB hub to give me 4 USB ports, which was attached to the back of the desk for ease of access, and for power I simply connected the laptop's original power brick to the power port extension. Now the laptop can be slid in place, which is super satisfying by the way, and powered on.
Ooh, okay, so this is pretty big design improvement over mine right there. That is a good design improvement, not gonna lie.
And used some tin snips and files to make a little cutout in the middle.
Design is that I have to pull the laptop out every single time to power it. And it can be quite a hassle. What if I can just okay, this is good.
Sandpaper to add micro scratches to its surface, which should give it a brushed look. This used I showed you earlier. Screws stand by to do nothing. You can even set up dual monitors with this, and when you're ready to go, the laptop can simply be pulled out and you can be on your way. Now it's worth noting that to successfully make one of these, your laptop must have at least a monitor port, a power port, and a USB port along a single edge. Doesn't matter whether it's the back or one of the sides, as if it is one of the sides, you can make it so that it slides down vertically instead. So I hope you've enjoyed this. Like a little cutout in Microsoft. Very nice. Now you may have noticed the 4 holes on the base. These are mounting holes to allow it to be mounted onto a wall. For this, it's just a case of using a pen to simply be attached to the back of the power brick, super satisfying by the way, and powered on. As you can see, it looks really neat, especially compared to the other methods I showed you earlier.
Okay, this is actually pretty smart. When we're placing ring now clockwise, cable comes straight down, the dial will stay in the right position. Gravity yeah. This is actually a pretty good point. Duct tape mine to the wall. Some have 15 laptops do nothing that have no ports on the same edge. Yeah, you do need them to be on the same edge. Thunderbolt 3 I'm about to end this man's whole career. Not really. Even though the Thunderbolt 3 is very convenient, I am using one too. But some people like to have 3 monitors set up because some of them may be accountant, people who have to work with reference material a lot, and yeah, having enough monitor ports like HDMI DisplayPort is very beneficial. And like, I don't think people like to plug in and out 3 USB cable every single time they work with it, because let's think about it. Some people like me have to have a PC, the one you are seeing right now, that I'm working on, and the other one is the laptop. I have peripheral that are my keyboard and the microphone. I don't want to have to plug out the name every single time I use it, so I just plug it there. Wait, what am I saying? No, sorry. That is not the point. The point is you don't usually have all the ports in one place. Yeah, if that makes sense, because I still have to use a separate HDMI cable for the 4K monitor, and that is why Thunderbolt 3 is not that good. And even so what, you still need connection format for this. And get this, even though the cables are quite cheap, you may have some lying around home, the dock is gonna cost money. The dock is definitely gonna cost money, so yeah, make it as you will. Now, the epoxy solution is a good suggestion, so I'm gonna search one epoxy. Yep, okay, not this one. Let's read the suggestion. He did make the good point about the Thunderbolt. Yep. The Thunderbolt is a lightsaver, so that way I don't have to plug in 1, 2, 3, 4, 5, and potentially 6 cable just to get to work. because this is 3 years ago. So put laptop on my desk. Yeah, some people don't like a big laptop on my desk, and the ThinkPad T14 Gen 1 is quite small, but so is my desk. I don't want anything cluttering it up without adding any value. It just clutter my mind. I may be autistic. It was really design that never they was love you was yeah. Is hot glue a viable solution in this case? Because the point is people don't just 3D print or manufacture for every single thing. For example, custom ear no in ear monitor. Yeah, they have to make it custom fitting. So even though these things are pretty good, they do make custom fitting so that they are sealed completely over the ear and preventing any audio escape. And yeah, that is super nice and can only be achieved by getting fitted.
Okay, so there might be a little bit of pressure perhaps.
So the
but
main
it
point
feels
of
like
getting
going underwater.
if this method is just soft material filling all the places and then it get hardened.
Yep.
That
That
is
is strange
basically it.
sensation.
All right.
All right. Here we go, slowly. It's coming out. And it's now filling up the ear.
Hey guys, back at NAMM, we are over at the Ultimate Ears booth, and we were talking with Vincent, who is head of Ultimate Ears.
Yeah, so my
Yes, same method. It's not glue viable. That's a good one. Do I need to wrap my ports into something? Actually, the hot glue solution sounds pretty nice. I'm not gonna lie, but I want to find a way to execute it well enough because at the moment it is quite sloppy. And let me see. Give me a second. There's a lot of excess material. I should just cut it down. Cut. Because there's a lot of empty space in this. I can't do anything about it, even though I want to. So let me just turn on the light. There we go. Okay, so the main objective right now is to cut it back on the gaps, so like we made it a better fit, a much better fit. So the hole must to be much closer than this, almost like perfectly match the dimension of the ports in order to for the gluing method to work. Now I'm going to make some more measurement because current setup doesn't work that well, and I don't know what you think about it, but I'm thinking about cutting down on material used over here. I don't think I should use that much material for something that doesn't add any benefit. So the downward portion, yeah, it's good because the upper portion is used, and this thing will provide a good base for the whole thing to stand on its own, and a lot of gluing area down here. So hold on a second. So I will, what is this? Laptop housing, laptop pocket, laptop ports pocket. Okay, this is the one. So we're going to edit this sketch. Okay, wrong side. I am modeling from the back. Yep, from the back. Wait, or is it the front? Yeah, sorry, I just forget. I forget how. Okay, the bevel it's like an arrow pointing to the right. So this is the front. This is the side. The hole when looked from the front, and the operation up here is through all. Yeah, that is why the hole is going through all. Now let's make some adjustment. So what is the dimension of this thing? 14 millimeter. Okay. Let me grab a quick look. Ooh, just hit my caliper. Let's plug in the HDMI cable. So it is raw true to the nature of the experiment. I think to find the profile of the HDMI cable is a good indicator of this. So I'm just gonna measure. Nine point 9.98, 9.6. I'm trying to get a much better fit for this thing so that we can be a bit more accurate. 9.61, 9.48. The HDMI is not totally balanced, so it's really hard to get a single measurement, but I think I can use the dimension of the HDMI cable. Wait a second, 9.63. Yeah, 9.63 seems to be correct. So like 9.7 should be a safe number. Yep, 9.7 should be a safe number. Yes. I really hate it. The fact that my caliper is now bent. This thing isn't cheap. It's not top of the line. But yeah, knowing that your caliper is bent, it really sucks. Okay, so 9.7. Yep, 9.7 is good. Good number to start with. Now, 9.7 millimeter. So nowhere near the number we got before. Okay. So from this side to this side should only be 9.7 millimeter. Okay, how do we adjust for this? Because we still don't know the perfect dimension of this, to be honest, and we do need a way to fit this thing down. So I was thinking about going for 10 millimeter. Yeah, going for 10 millimeter and try to fit it in, maybe. Because this thing is now is way too big. It is way too big for this. Let me make some observation. Give me a second. So I'm pushing the laptop completely into the lid so that I can measure much better. Push it completely in. Okay, let's try to make sure adjustment. From the outer side to the side of the HDMI is 12 millimeter. So the distance from the lid, the upper side of the laptop to the Thunderbolt, look to the HDMI is 12 millimeter. Okay, how many millimeter is it? Let's quickly write that down. So this is the lid. This should be 12 millimeter. And from the other side, so this thing tiny number is currently 3 millimeter. Okay, I was being stupid. 3 millimeter, and instead of trying to constrain it this way, we're gonna delete the constraint and add a dimension right here. So this section will be 9.7 millimeter. That is much better. We're gonna still put a hole through it, and the result will be a much tighter hole. Now, this thing seems to be more of a eyeballing, so yeah, I should change this. Laptop ports pocket. Because I don't remember why I made it this tall. You know what? I think this dimension is actually okay. It's not a problem for it being this tall. Maybe I can cut it down a little bit. Trim it a bit from that side and this side. So how do we measure this part? Using this part ruler caliper. So we subtract another 4 millimeter for the top of the HDMI cable. Now since this thing will be flipped, we will have to subtract from the bottom. Yep, we're gonna have to subtract from the bottom up. 4 millimeter. $196. Okay, I think it's pretty good. I might be able to create a prototype tonight if everything goes well. Yeah, now we will move on to modeling the power brick section. can now. So let me just check up on the dimension of these things. The power brick, this thing, housing, laptop charger thickness. Okay, this is the sketch that we use to define. Measure twice, cut once. That is what they always say. 109.3 millimeter. $109.4 millimeter. Is it correct? 100. So have 109 plus 4 plus 4. We have 117. 115 over here. I want 3 millimeter wall on both sides. So what happened to me last night? $109.3 millimeter. Plus 3 plus 3 plus 3 is 6, so overall 6 millimeter. 115.5. I think I should add a half millimeter. Yeah, half millimeter, so it is a little bit easier to fit. So the length of this has been accounted for. Okay, I did a pretty good work last night. About the other side, 47.2, 47.43. It seems to be different at multiple section, which makes sense. These things get hit up a lot. 48 millimeter should be a good design number, so this thing can, yeah, so this thing can be can be covered. So 48 millimeter. Let's see. 48, 47.2. This is the absolute number, right? Yep, 47.2. I should give it a 48. No problem with this, right? Okay, perfect. Now, because I want the back to be, I want the back of this thing to be sub in, and to be honest, I want the overall design. So let me just change it up a bit. Okay, I want to edit the vent of this thing, but instead of this section taking so much space, I'm going to I'm gonna delete the tangent. Okay, that is not the one. Maybe this one. Okay, we want this point and this point to be coincident. What the hell? This point and this point. Okay, coincident. And I should make another line, make another reference. Turn up. Oh shit, how do I do that? I think okay, I can see it now. I want to add another reference geometry. Right. Oh, okay, give me a second. I'm gonna have to close the window. Lock down noise because insect cannot tell the difference between 300 watts of power and the sun. Okay, I think we are locked down. The room is gonna become a sauna anytime, but whatever. It's not like engineer takes a bath anyway. takes a bath anyway. Now let's create some reference geometry. Okay, now we got it. So we now got a reference geometry. I want this point and this point to coincide. Why doesn't it works? It's not coinciding. Something's wrong. Oh, it cannot coincide. Okay, so this line and this point should coincide. Okay, there are still a couple more degrees of freedom, but the main idea, so let's talk about the main idea. The main idea is to create a cutout in this direction and another cutout in this direction, so that the lower part of the charger can sit. Yeah, I want to just create some sort of smaller walls so that the laptop can comfortably sit. Okay, how do we do that? Now first let's just focus on the main cutout first. I have made it this one is 9mm, right? So the 3mm thickness up the bottom, and add another 6mm onto the side level. I think I can go a little bit more than that. Let's check it. Let's see. How much can I add to this thing? And it really sucks with the caliper. Seems to be 13.62, so 12mm be a comfortable number for this thing. Yep, 12 millimeter from the bottom edge. So instead of 3 plus 6 is 3 plus 12, which is 15 millimeters. Okay, we got that down. Now there's this degree of freedom, because yep, there is no coincident constraint right here. And the green part, can I still move the green part? So no. Let me just create another geometry reference this line right here. Wonderful. So I can do this, select this point, coincident. Wonderful, wunderbar. Now I already got this thing down. Let's close the sketch, and yep, I got a hole exactly where I want it. Now I want, so the cutout should be on this side, but preferably big enough so that both of this can fit through. So a pretty big cutout. Let's create a sketch so we're going to sketch in this plane, right? So the YZ plane. The reason I stopped sketching directly on the face because it is a nightmare to fix. So many problems with the face disappearing, because once you edit one thing, it gonna affect all the other faces, which is not what we want. Now we already create that, and we want some reference. This will be good reference point. This point right here. Did I just select? No, not that. What is wrong with it? Okay. Now let's take some measurements, shall we? I don't know. I forgot how to do that. Is it take the caliper down to this? YouTube time. I should add a little bit more energy. My mentor in the company, she is a super energetic person. So how to measure using Finnick caliper. Although she is like in her 30s, she have a lot of energy, and I wish I have that kind of energy.
Vernier calipers are the most misunderstood calipers out there. Fully as accurate as digital calipers, anywhere from 0.02 to 0.05 millimeters in accuracy. If the drill bit would leave, then the cutout faces away from the wall, ensuring you measure to the top. Vernier to ensure you're square on something, tool that the hole might have. However, if the hole is conical, as with the drill bit would leave, then the cutout faces away from the wall, ensuring you measure to the top of that cone. Next, we have step measurements, which are done with the front part of the tool, and this is the least known measuring capability of a caliper. Yep. As the name suggests, it measures things that have the shape of a step. Push the calipers open a little bit and set the step on what you want to measure. Then, holding the shaft, push down to the desired measurement. Again, ensure the calipers are as flush and straight as possible with the surface. Okay. And this is how you measure steps.
Okay, so by that same logic, I can put it down here. Yep, it's working. Ooh, this feels super weird, but because the part is moving is the long ruler thing, not the small one. 7.17 millimeter, 7.42, 7.5. So 7.4 should be a good number. Yep, 7.4 from the inner face of this thing. Okay. Now just 7. What the fuck's wrong with this thing? Let's just make it 7. So we have a lot more wiggle room. I'm still not good at accurate stuff, so I will even measure. No, okay, so we don't want this. We don't want this also. We want the inner diameter. We like inner dimension of this thing. The top one is cool. Okay, so yep, this is the inner one. So this is at the bottom. This right here, I believe is no. This is a little bit redundant. I believe so. Yeah, it's actually a bit redundant. But whatever. Inside, that is the face we want. Inside of this. I think the whole cutout, we cut out a little bit too much. But I think, like, can we cut out through the whole thing? Would that affect the structural integrity of the whole print? I don't know. Maybe not, but it's it's worth a shot, right? Like, we have a 3D printer already, so why not use it? Okay, very interesting. Now we're going to sketch it. Okay, using the step measurement method, I will measure it from this step down here, 7 millimeter on one side and 7 millimeter also on the other side. .9. So should I just use 6.9 millimeter? Nope, I think 7 millimeter cut out from both sides should be good enough for our purposes. For our purpose. I think I just got the wrong measurement again. Delete that. Go into this, press this thing, click here. Looks pretty weird, but okay. Actually, it actually makes sense. But let's sketch it using a rectangular tool and define some constraints. So the dimension in this part should be 7 millimeter, and so is this part right here, 7 millimeter, and from the bottom up. Yep. From the bottom up, it's actually a bit more tricky because there is a fillet down here, so I don't think a step measurement would be good, but it's worth a shot, right? 12 millimeter, of course, with some very generous wiggle room, half a millimeter of wiggle room to be exact. So on one side 12.2, on the other side which is also 12.2. Okay, so 12 millimeter is good. So the bottom up, right? This side to this side is 12 millimeter. Now we do have a lot of degree of freedom here, but I just wanted to completely cut out, so we'll select the two line, we'll select the tangent, and we are done with the cutout. Now the pain point of this is about moving the sketch. So I got it right the first time is about the attachment offset, the position of the attachment. So it is currently attached to the YZ plane. We want to move it, but we are not moving it according to this. So we are not moving it according to the x-axis. We are moving it according to the z-axis, because according to FreeCAD, for some reason this is the direction, the z direction they are thinking about. So they are not using the absolute coordinate system. Okay. Oh, they are also showing all the sketches in the same plane. Neat. This one Z, so how about 5 millimeter? No, it's -5. I try to get as close as possible. Seems to be touching, right? Yep, so -8 millimeter is quite close. I just have some problem, so this is a cutout, right? It's okay, so I will name this laptop charger power cable. We create a pocket. We select through all. Boom. So this side is the one that we will receive. We receive the fillet, but yep, it's good. Okay, we got it down. Nice. Very nice. So I think at this point I should. How long have I been recording? Almost an hour. Yep. The pain of learning. Can we create a group? No, we cannot. So it's like a tree thing. I think the major selling point of this tool is the ability to quickly do some adjustment. So we're gonna do it right now. So we're gonna cut through the whole thing. Vent. Okay, the vent. We'll select this. We'll select 40 millimeter is actually good, but we want to go through all for the first time. Okay. Okay, it hit clean through the thing. Okay, so that's good. We're experimenting, so like Bob Ross usually said, is a little happy accident between us. FreeCAD laptop dock. Okay, let's fire up my baby. busy with work all week, so didn't have the time to do this. Let's go. Let's go. Missing. Loading time. When we want this face to be flush with the bed, we want to rotate it 90 degree so the inertia from the printing doesn't destroy it. We want to cut down as much material up here as possible, so we're gonna select the C, the cut tool, move it this plane. We're gonna give it a teeny bit more space up here and perform cut. Now this thing is now cut. Back. Which is the redundant part? Okay, so it fits perfectly inside the thing. So I'm gonna delete that. We'll use the multi-board tiles. Let's see. Floating cantilever. Yep, I know it. Is that those parts? Oof, I should really. Yep. I think this is an oversight. We can definitely fix it. No. My stupid ass. No, we don't want to save it. Yes, cantilever design is bad for the design. So we don't really need this part right here, right? So how about we just let the vent, because the vent is cutting from this way, from this direction. We can just clip this thing off. Vent. Well, we want to edit the sketch right here. We remove this tangent and we choose oh shoot, how does it work? Okay, there seems to be a bit of a problem here. What is the constraint we are using right now? So coincident. Sketch has redundant constraint. Yes, can you tell me which one is redundant? Maybe it's the new constraint. We can delete that. Let's not do something rash. We are just going to create a polyline. Poop. Oh fuck. Nope. Make this and this. Okay, because there is now a lot of degrees of freedom. This thing and this thing should be parallel to each other. Parallel constraint. No, this is equal, right? So parallel constraint. Yeah, parallel. Nice. Damn, I'm super smart. Okay, close this thing, and now it completely clips it up and leave us a bed down here. Wonderful. Now we'll delete the old file. No, are there any weak point in the design? I hope not. You know what? We already make a vent here, right? why not just make a bigger one? Since now we know how to edit these things, we can just cut out a giant hole. Yeah, nothing can stop us, right? 120 by 90. Okay, this is the number we want, and the whole thing can now move. So we'll select this line and this line, make it parallel. Nothing is working. What the error? At least 2 lines. I did select 2 lines. What the hell? Okay, maybe this will be easier. Wait, what? This line, parallel. Nothing. How do we lock this thing down? Do we even need to lock this thing down? I don't want to. Can I just leave it right there? Seems to be enough. Of course. File, export. Blah blah blah. This thing. Very hollow. Please, it seems like we have floating. Where? Can you show me the floating cantilever? It's just overhang, right? I can't see any floating cantilever. Maybe this. Of course, I know this is the part where it needs. Where is the floating cantilever? I know there is a lot of overhang, of course, a button of overhang, but nothing seems to be a cantilever. Maybe the cutout is a bit too big for this to flow over, because from what I can see, everything is fine. Every floating region is supported from both sides. So no, is this a little bit too much? Yep, I know you say that I'm under constraint. I know KiCad. So I'm gonna close this. Select the body, file, export, STL, overwrite. Okay, You want support? You got it. Show me where I need to bring the support in. The whole thing, the whole fucking thing. Okay. Still have no clue why that thing is a cantilever, but okay. I want to push the limit of the printer. So let it be. I want to see how it fell. Export. Yep, I don't want any support. I just wanted to print wrong direction. 90 degree. Much better. I may be pushing it a little bit too hard, but let's see where the fucking cantilever is. Print. I don't give a damn. I want to see it. Okay. The printer is downloading. I think it will be enough for tonight. See you around. And stay tuned for my next post. Whether if this thing will fail or not. How long that this thing will take? 7 hours. So when I woke up, this thing should be ready. Nope. Save. Close. And good night.